with this graphing day 2 activity. The bell ringer is what we did yesterday. So what we would do for these types of examples is set each one and find how to graph it. So you have two ways to graph. You can graph by finding your x and y intercepts, or you can graph by finding the y equals mx plus b form. For number 1, if I found my x-intercept, that occurs when y equals 0. So for the first one, when y is 0, x is 2. Because 3 times 0 is 0, and that gives x equals 2. So that gives the point 2, 0. I did that because in this first equation here, if you solve for y, we get negative 1/3 x plus 2/3. And that 2/3 isn't exactly a very nice starting point as a y-intercept. So what I did was find the x-intercept instead. And then I can still use the idea that my slope is negative 1/3. And from the x-intercept, I'm going to go down 1 and over 3. Or up 1 and left 3.
Yay!
Good. And then we're going to do the same thing for the second equation. So again, you can either solve for y or find your intercepts. If I solve for y, I get 3y equals negative 3x minus 6. Dividing everything by 3, I get y equals negative x minus 2. So my y-intercept is negative 2. My slope is negative 1. So that's down 1, right 1, down 1, right 1. Or up 1, left 1, up 1, left 1. And then connecting those points, I see that in fact these two graphs intersect each other. So that tells me I have intersecting lines, which is an independent system. And my solution is that point of intersection, which is negative 4, positive 2. So again, my solution is that point of intersection, which is negative 4, positive 2. Moving over to example 2. Once again, the goal of this is to graph our equations. So maybe I solve for y equals again. So I get y equals negative 2x plus 5. My y-intercept is a positive 5. I'm going to go down 2 and over 1. We're going to solve for equation 2 as well. So you add x to both sides. So I get y equals x plus 2. So my y-intercept is 2. My slope is positive 1. Connecting those points. Once again, I see that my two graphs intersect. And they intersect right here. So that means that these are intersecting independent lines with one solution. And that solution is at 1, 3. So I have intersecting lines that are independent and they have one solution at 1, 3. So that's a summary pretty much of everything we've done in 3.1 so far. Today we're going to do some stuff on the graphing calculator. So our goal today is to learn how to utilize the graphing calculators. If you don't have a graphing calculator, you can borrow one from back here. I have also sent you guys some apps. I can send them again so that if we have a homework assignment and you need a graphing calculator, you can use the free apps to use this. So go to your graphing calculator. Mine and yours look a little different. That's okay. So we're going to be entering this data right here for weeks with Ed and Joe. So you're going to turn your calculator on. We're going to clear it out. So you're going to hit to start. You go to stat. And then we're going to go to option 1, which is edit. Now, there's going to be data in there. That data is not going to match what we're looking at right now. So you can arrow up so that this is highlighted and hit the word clear and enter. So clear is right here. So you're going to arrow up and over. So I highlighted L1. I'm going to hit the clear button, and I'm going to hit the word enter. And then all of my data should be gone. Now what we're going to do is we are going to go and enter in weeks. So you're going to type in 1, 2, 3, and 4. And then we're going to start with Ed. So we're going to enter in Ed's numbers and match them up to the week number. And then we're going to hit the word stat again. You're going to go to option number 4 under calculate. So you're going to go to calculate and down to 4. Now yours, it's going to look a little different than mine. You're just going to hit enter. If you have the newer calculators, you have to go down and highlight calculate and hit enter. So yours, it should say done, but you're just going to hit enter. Mine, in some of the newer calculators, you have to go down to calculate and hit enter. The A represents our slope. The B represents our y-intercept. So that means for Ed's equation, it's y equals 5.9x plus 44. Ed's equation is 5.9x plus 44. We're going to go do the same thing, but now we're going to look at Joe. So you're going to hit stat, go to edit. What's really nice is that I don't have to change my L1 values. I only need to change L2 to match Joe. So I'm going to type on top of the 50 the number 40, then 47, then 56, then 62. And then the steps after are the same again. You go to Stat, go over to Calc, go to Option 4, and calculate your information. You should not. Make sure you typed on your data. So you should type in Joe, again, I told you the packets are a little wonky. Joe goes at the top of the next page. He's 7.5x plus 32.5. So we're using our calculators to find information like we did in the past. So what you're going to do is you're going to hit y equals. If there's stuff typed in there, go ahead and hit clear. Get rid of whatever's typed in there. So you're going to y equals right here. And then you're going to type in those equations. So you're going to type in 5.9. The X key is right here below mode. And then plus 44. And then you're also going to type in Joe's numbers, which are 7.5x plus 32.5. Okay. Now, in order to graph this successfully, we have to be able to interpret our data. So weeks and number of shoes. What do you think would be a good domain or starting point for X? Okay. And then obviously at week 4, they don't sell the same number, but they're pretty close. So maybe we want to talk about 10 weeks worth of sales. So you're going to hit the word window. And X-min represents domain. X-max represents domain as well. So I'm going to make my min and max the 1 to 10 to represent week 1 to week 10. The X scale doesn't matter all that much. Oh, I just drew my calculator. So you can make it a 1, a 2, it doesn't matter. It just represents the tick marks at the bottom of the graph. And then my range, what's kind of like the highest and lowest numbers on here? Good. So I know my min could probably be 40 since that's the lowest. But again, I need to go beyond that because I'm looking for an answer, so I might go out to like 100.
So for the domain, did we have to go to 10? Like, did we have like 1 to 10? Did we do like 1 to 4? Or did we have to go higher?
So if you go 1 to 4, you're not going to be able to see the graph's intersection. So the reason you go beyond both the highest on the domain and range is so that we can see this point of intersection. To get to graph, you're going to hit the word graph right here. I would hope so. Did you guys enter information in y equals? If you hit y equals, do you see those equations?
Yes.
Did you change the numbers in your window?
Yeah.
And then you hit the word graph, and you still don't see this? Okay, go to y equals, is plot highlighted, and are the equal, like, this should not be dark, and this should be dark. If plot's darkened, turn it off. So you just go up and hit enter, and if these aren't darkened, you go to them and hit enter. And you hit the X key below mode, not like down here. What?
Mine works now because the plot was darkened.
Okay.
I clicked that. I clicked the right tab.
I'll look. Hold on. Okay. So what you're gonna do now, guys, is what's our purpose? We're trying to find where they what?
Intersect.
So I want you to hit the blue key that says second. Yours yellow. Sorry. And then you're going to hit the word trace. It's next to the word graph. What do you notice about one of those options?
It says intersect.
Yeah, it says intersect. You're going to go to option 5 for intersect. And you're going to move your little blinky cursor to about where they intersect. And then you're going to hit the enter key, not once, not twice, but 3 times. Yeah, it's like the first graph, the second graph, and the guessing graph. And you should be able to get 7 and 86. That represents week 7 and selling 86 shoes.
Why can't we sell to like adjustable? Does that matter? I don't know why it's somewhere else.
Yeah, I think everybody.
You change your Y values. You only change directs. That's why you see nothing. You need your Y values to also match our data from the 40 to like 100. Yep. Okay. So we're gonna look at one more example.
Man, calculators are so cool.
They are pretty cool. So again, at week 7, they would both sell 86 shoes. Let's go down to the Olympic information. So you have to be careful in this example because it says X represents the numbers of years since 1968, not the year. So it says numbers of years. So you'll notice in my table, I scratched out and changed them to be different numbers. So 1968 represents year 0, because from 1968 to 1968 is 0 years. From 1968 to 1972 is 4 years. So in my table, I'm going to put the number 4 instead of 1972. And then since these are Olympic races, except for this year, the Olympics occur every 4 years, except for 2020 because it's 2020.
Yeah.
We just didn't have the Olympics. So the Winter Olympics are every 4 years and the Summer Olympics are every 4 years. And then every even year is an Olympic. So these are all on the even years from 1968, occurring every 4 years. And then what we're going to do is we're going to compare the men's times to the women's times. So you're going to go back to your table. You're going to go back to edit. X is always related to L1. So X is always L1 and Y is your L2. So in L1, we're going to put the years since. So that's 0, 4, 8, 12, 16, etc. All the way up to 32. And in L2, we're going to put the men's times to start. And then we're going to go to Stat and Edit and find our equation. And when you have really long decimals, we like to only write out 3 of them. So 3 decimals is always a safe bet. What? So what I want you to do now is try typing in the women's times and getting your equation after you get the men's. And then we'll compare your answers with my answers and make sure everybody can correctly get the men's and women's equations. Okay. And did we get negative 0.00 or 0.88x plus 50.860?
Is it okay? Like the calculator just rounded up to A. Mine's not 0.09.
That's okay.
Santino, Zulu Hall, please come to the office. Santino, Zulu Hall, please come to the office.
All right, so just like the previous problem, we want to find their point of intersection. So we're going to go to y equals. You're going to clear what you've typed in, and you're going to replace it with the 2 equations we just found. And honestly, the hardest part isn't getting the equation. It's figuring out the window with which you need to graph that equation. So again, we're looking at years and times. So we know at a minimum, my domain is going to be at 0 and then 32. At a minimum, it's 0 to 32. But it's going to take a long time for the women to catch up to the men. Because if you're comparing these 2 times here in 2000, they're really far apart still. So I'm going to think it's going to take the women a lot more years than I want to admit. But let's say like 100, it's safer to go further than it is to not go. So we're going to take our domain out to 150. So x min 0, x max 150. I got too close to my calculator, it won't focus. And then just so I don't have a million little tick marks, I'm going to make my x scale 5. And my y values, well, the slowest women's time was 52. So that's going to be my max. And then the min is going to be them getting faster. So right now we're at 43 and 49. So I might drop all the way to 35. Yeah.
So say for the X max, if instead of 150 I put 300, how much of a difference would that make? Like how high does it make? Is it like
It just, the further out you go, the smaller your graph gets. So the first line is the men, the second line is the women. I really need to paint my nails after all of this. It's all I can see. So we see that the men and women will eventually match. Now we know there's some falsehood to this, that the women are not going to continually get faster than the men. But the predicted point of intersection is here. So you go back to second, trace, go to option 5. Why are you guys giggling? And we hit enter 3 times, and we see that 100 years after 1968, which is 2068, which you guys could be alive at, they should both be at this speed. So you're turning to the next page in your packet, and you're finishing for Thursday up to problem 31. So you're going to answer part C, and then you're going to skip D at the top of the next page and go to 31. So do C, skip D, and go to 31. What? Oh, yeah, sure, honey. I will see you all back here Thursday. I have no idea. I'm on like a 1 day at a time.
Have a good day, Mr. Brett.
Thanks, Hannah. You too.